Hi, I'm Matt with Schematical, and today we're talking. Hi, I'm Matt with Schematical, and today we're talking about sharding. We're going to start off with something really simple, Redis. Before we get too complex into the details, basically it's how to scale your database servers without breaking the bank, how to horizontally scale them. If you vertically scale them, especially in AWS, each size you go up basically doubles the amount you're paying per server. But if you can figure out a way to horizontally scale them, meaning that you can boot up a bunch of servers in parallel that each have different data sets on them. You can save a lot of money and be much more precise and strategic with it. Let's get right into the examples here. So this right here, by the way, notice the cool little stars kind of animated in the background. I just added that to the diagram stuff, which you can sign up for if you'd like to. Link should be in the show notes or schematical.com. So right here, we've got our application layer and our Redis server. We're going to just skip everything else. We're just going to focus on these two parts of the network map right now. And so normal function, the application layer sends it a request, and after a while, we start getting more traction, and boom, the server starts to struggle. So then the typical notion is to go ahead and boot up a bigger server. That right there doubles the amount of money you're spending. Same thing happens. Instead of business just as usual, eventually we get more traffic because your site's growing and that you want that. But at the same time, then you got to go back in and boot up a bigger server. Now, it'd be nice if you could do 3, but that's not the way that the tiers in most hosting platforms, especially AWS, work. They're about double each time. So there we go. Now we've booted up this and your bill grows accordingly. But we don't want that. So the easiest thing we could do is we could create some read replicas. There we go. There's our replicas there. So let's see how that flow works. All right. So that sends it to the master server, which then will propagate the changes out to the other servers. And so the replica 1 stores it in its key value there, and replica 2 stores it in there. So now the application server needs to do a get. It goes to one of the replicas, taking load off the primary server. It's pretty much how it works with MySQL and anything else that has master replica type setups. Hey, there's our hello world. By the way, let me know what you think about the new font here. I'm just playing around with a bunch of different fonts. So the problem comes not when you run out of CPUs, because this helps with CPUs, but when you run out of disk space. And typically when you increase the amount of records you're querying, you need a little more disk space to query that. So at a certain point, when you have 1 billion records in there or more, you're going to run out of CPU. It's just they don't make CPUs that big. So how do you scale this thing cost effectively? That's where sharding comes into play. And the beautiful thing about sharding is with Redis, it's so simple. A lot of other ones, you got to figure out what the shard key is, the partition key, etc. With Redis, there's only ever one key. So you basically just hash that key, and that's kind of how you figure out which shard it should be living on, or partition, whatever you want to call it. In Redis, it is sharding. I can go a little bit into how the hash math works if you want me to. Maybe leave a comment. I'll make a separate video for that. But for now, basically, we hash it, and depending on how many shards we have, you know what? I'll come back to that. Skip that. I'll come back to that. Now understand, I'm grossly oversimplifying this, but let's take a look at what it looks like with 2 shards instead of replicas. And you can have replicas on these shards. I'll add that later. But right now, basically imagine, and this is not the way we actually do it, but imagine if the key started with A through M, the letters A through M, then it goes to shard 1. If it starts with N through Z, it goes to shard 2. Now, in reality, that would not likely make for an even distribution of records, so that's why we use the hashes. But for the purposes of our example right now, let's just imagine we're using the letter, the first letter of the key. So, in this scenario, H set AAAA would go to shard 1. And so if you wanted to retrieve information we'd know that if it starts with A, then we'd go ahead and retrieve it from shard 1. Here, because Z is N through Z, it would end up in shard 2. So we store it in shard 2, we retrieve it from shard 2, and never ever does shard 1 get hit for those type of queries. We don't waste a lot of compute power. Both of them have separate, completely their own disk spaces. It's really an ingenious way of doing it. I didn't come up with it. I'm just trying to explain it using pixel art to you. And of course, just like the other ones, each one of these can have their own team of replicas behind them. Yes, in case it's not clear, I'm saying shard, S-H-A-R-D. So in this scenario, we still get the same benefits of having a replica, a read replica, where we can take the traffic load off of the master, the writer, if you will. But in this case, we still have it's sharded. So shard 1, replica 1 will have completely different data stored on it than Redis shard 2, replica 1. So they're both just parallels of each other here. So that's like 1,000-foot view of how Redis sharding works. If you want to get deeper into this, I know Postgres has partitioning. DynamoDB is pretty amazing because it comes out of the box with it, but it's kind of a pain unless you really understand what you're working with. But a good starting point is this. Additionally, I do have Terraform scripts, not in a module form that I'm ready to open source yet. I'm a bit ahead of myself on this one. But that will allow you to do this. So basically, you're going to create a replication group. The number of node groups is basically your number of shards. So that says 4, but if I flip it to 2, that's pretty much what you saw on screen right here. And if I up this to 4 or 5, then you'd see 2 more groups of these things over in the side here. I'm not going to add them now. You want to have your ElastiCache cluster set to 0 because this replication group will actually handle how many clusters there are under it. So you don't want to boot up an additional one on top of that. It's a little confusing. Actually, you might be able to omit this altogether. But I found that setting this to 0 will get you past an error where it says it can't do clustered enabled while you're trying to boot this up. Now I think about it, I could probably just delete this. Either way, that's all for today. Just a brief introduction into sharding. If you like this, if you found value from it, please go ahead and hit the subscribe button. Check out my daily mailing list. Also check out my free ebook that is most likely linked in the show notes. 20 things you can do today to save money on your AWS bill. Additionally, I consult on this, so if you need some hands-on help, I'm here to help your team, as well as I do group coaching. So check it out on schematical.com. Without further ado, thanks for watching. Additionally, I do have ElastiCache scripts. Oh my God. Whoops.